Reach me down, my Tycho Brahe. I would know him when we meet, when I share my later science, sitting humbly at his feet. He may know the law of all things, yet be ignorant of how. We are working to completion, working on, from then to now. Pray remember that I leave you all my theory complete, lacking only certain data for your adding, as is meet. And remember, men will scorn it, 'tis original and true, and the obloquy of newness may fall bitterly on you. But my pupil, as my pupil, you have learned the worth of scorn. You have laughed with me at pity. We have joyed to be forlorn. What for us are all distractions of men's fellowship and smiles? What for us the goddess pleasure, with their meretricious smiles? You may tell that German college that their honor comes too late, but they must not waste repentance on the grisly savant's fate. Though my soul may set in darkness, it will rise in perfect light. I have loved the stars too fondly to be fearful of the night. Sarah Williams.
Hello, and welcome to the Scientific Odyssey. The Scientific Odyssey is a mini-part journey into the history and philosophy of science. My name is Chad Davies, and I'm the writer, host, and producer of the podcast, where we consider the ideas, processes, and results of over 2,500 years of scientific inquiry and discovery. Series 3, Finding Our Place, Episode 51, Epilogue.
Like the waves casting away from the shore, we left our homes, our comfort zones, into new time zones. Like the waves gaining strength as they form across the ocean, we too became stronger and grew with each passing day on semester at sea. Like the waves crashing back to the shore, we must return to our place of origin. But like the waves, we return in different form, having seen the other side of the world. Cassidy Arts.
And so it is, here and now, that we find ourselves finally gliding into harbor at the end of our long journey. As we approach our moorings, I think we can take a bit of time to look back over our travels and remind ourselves where we've been and what we've learned. We can gather together the great themes of our investigations and place them in proper perspective. Most of all, I think we can celebrate a voyage well made and toast our arrival at this time and place. So what have those themes been? Well, for me, there are a few worth taking some time to specifically point out. The first is the incredible creativity and ingenuity of human beings throughout our existence. I would say history, but what's clear in this area of inquiry is that our curiosity and our desire to understand the heavens above us go far back before the invention of writing. Among the earliest artifacts associated with human beings living in groups are rudimentary records of keeping time by the phases of the moon etched in bone. Older still than those are the stories associated with the sky and the influence our orientation and their orientation had on our cultures. Even before there were pyramids and dragon bones, the arising civilizations in Egypt and China looked to the region near what we call the North Celestial Pole and found a permanence and unchangeability there that led to profoundly stable societies that endured not just centuries, but millennia. Other cultures, those of the Fertile Crescent, saw the ever-changing belt of the ecliptic and sought to discern patterns in order to predict the will of their capricious gods, and in doing so began to try and quantify change. In every culture, on every continent, there were efforts to understand the intricate and complicated dance of the celestial bodies, and in every case, the culture was successful in teasing out the multiple, disparate movements in order to learn to keep time and distill regularity from the seeming chaos of random occurrences. The motions of first the moon, then the sun, then the 5 other wandering lights were observed and remembered, and then resolved into patterns that allowed game to be hunted, crops to be planted and harvested, and seasons to be followed. Before there was civilization, there was astronomy. The discovery of these patterns and rhythms tells us that our distant ancestors were as clever with the sky as our modern scientists are with their cutting-edge technologies. While they may not have had the tools we possessed, what they figured out with their eyes and their minds is truly remarkable. And that creativity was not just limited to them, but can be seen through so many other newer stories. Whether it be the use of shadows to measure the earth, the properties of glass to focus light, the separating of that light to determine composition, or the development and use of mathematical tools to model the motions and processes of those things in the heavens, human beings have never let their limitations stand in their way in the quest to learn and know more about the sky over their heads. That we can take the feeble light coming from the surface of a distant star, focus it through a telescope using the laws of optics, and shine that light on a spectrometer that breaks the light into its myriad wavelengths so that we can not only know the temperature of that star's surface, but also what it is made of, how fast it is rotating, how old it is, and how it was born, will live, and how it will die, is to me one of the most remarkable accomplishments humanity has ever achieved. It is based on work done over generations of trained and dedicated inquisitors devoted to understanding what was out there, beginning with William Herschel, moving through the Harvard calculators, and culminating in the work of the British and Indian astrophysicists Eddington and Chandrasekhar. The second theme is what I call the journey from the center. In every ancient cosmology, humanity's place was at the center of the universe. It's an understandable conceit for human beings who experience the earth as being unimaginably huge to do this. However, over time, there has been a slow movement away from believing that we are at the center of all things. It began with those astronomers and geographers who understood that the earth was a sphere and that human beings lived on its surface as opposed to being at the center of that disk. Thousands of years later, starting with Copernicus, the next step was suggested that the Earth itself might not be the center of the universe, but was instead just another planet revolving around the sun. Proposed at a time when the enterprise now known as science was truly beginning to take shape, investigators such as Brahe, Kepler, Galileo, and Newton each took turns providing data, creating mathematical models, and forming grand physical syntheses in order to establish that the Earth did, in fact, move. 2 centuries after that, with the data first provided by generations of first astronomers and then astrophysicists, Harlow Shapley, Vesto Slipher, and Edwin Hubble would show that the Sun was not at the center of the enormous galaxy, that there were island universes, the modern pictures of galaxies as conglomerations of billions of stars, and that these galaxies moved away from each other in an ever-expanding universe which does not have a center. This last part of the picture was made possible by the work of that patent clerk turned academic, Albert Einstein, and those who were willing not only to follow his ideas, but to push them in new directions, to create new models that are still mysterious to us today. And it is in this particular journey that we have found our place. Human beings occupy a physical world made mostly of metals and silicate materials and covered in liquid water and a thin layer of gas that rotates on a tilted axis and travels in a geometrically closed path around a star we call the Sun. It is joined in its solar family by a myriad of objects, some that meet specific criteria that are called planets, 8 of which in total are now officially recognized. A score more objects that, like their planetary cousins, are large enough to pull themselves into spheres, but that orbit planets rather than suns. And then innumerable smaller worlds that have not managed to consolidate themselves into large accumulations of mass, but that orbit the Sun underneath its gravitational influence, nevertheless. All of these bodies formed with the Sun from the collapse of a small region of a giant molecular cloud that came together due to its own self-gravity. It is that central object, the Sun, that contains almost all of the mass of the solar system, and so gravitationally dictates the motions of the smaller worlds in an intricate dance of geometrical trajectories that are bent and shaped by the gravitational nudges of their neighbors. The Sun is powered by the energy derived from the conversion of mass into energy through a process known as fusion that, among other things, produces light that over the course of 2 million years makes its way from the Sun's core to its surface, where it is then emitted. Streaming outward from the Sun's surface, this light warms the Earth and provides the energy needed to sustain, either directly or indirectly, nearly all of the life on the planet. Yet, as we have come to learn, the Sun is just one of nearly 1 trillion such fusion-powered light factories that make up a huge collection of stars known as the Milky Way galaxies. These stars range in mass from monsters that are 80 or 90 times the mass of our Sun to dim red dwarfs that are but a fraction of its mass. Yet each produces light the same way and is gravitationally bound to the Milky Way through the mutual attraction of all the galaxy's members and material, including some material that remains a mystery to us even today. This Milky Way galaxy, shaped like a thin disk with a central bar-shaped bulge, rotates once on its axis every 250 or so million years, thus having turned completely, some 20 or so times in the Sun's 4.6 billion year lifetime. That Sun lies a little more than halfway of the distance out from the center of the Milky Way, a span so vast that it takes light some 26,000 years to travel from the stars near the center of the Milky Way, occupied, it is thought, by a supermassive black hole, to the telescopes that dot the Earth's surface. For comparison, light from the Sun only takes about 8 minutes and 20 seconds to reach the Earth, and the entire solar system is just a little less than 17 light hours in radius as measured by the Voyager 1 probe. All told, the Milky Way galaxy is estimated to be a total of about 100,000 light-years in diameter when the distance to the furthest stars is measured, though it is likely much larger than that when the distribution of that mysterious dark matter is taken into account. The Milky Way, of course, is not alone in this universe. It is part of a small group of galaxies, known as the Local Group, which contains at least 54 other galaxies. One other of those galaxies is also a great spiral galaxy that is twice the size of the Milky Way, known as the Andromeda Galaxy. And it, along with the Milky Way, gravitationally dominates the motions of all the other members, many of which are either satellites of one of the 2 big spirals or are in the process of being gravitationally devoured by them. This other vast conglomeration of stars, seen in the nighttime sky from a very dark location as a faint but visible smudge in the constellation of Andromeda, lies some 2.5 million light-years from the Earth. This local group of galaxies is part of an even larger collection of galaxies known as the Virgo supercluster, made of myriad smaller clusters like the local group scattered across space like some grand archipelago. Even this supercluster, though, is part of an even larger galactic structure that is part of the overall distribution of mass in the universe that resembles nothing so much as what might be seen on the surfaces of the connecting walls and lines of bubbles that make up the foam found on the top of a child's bath. These galaxies reside in a space-time that is expanding at an increasing rate, pulling the groups farther apart from each other, even as the individual members of the various groups are locked in a gravitational dance that pulls them towards each other, resulting in slow-motion titanic collisions that take place over billions of years, a fate that may await the Milky Way some 3 to 4 billion years from now in a collision and merger with the Andromeda Galaxy. Yet, even as spectacular as all of this sounds, we must remember that such processes are taking place all over the observable universe and in the 100 billion galaxies that we can see within it. It is imperative for us to understand that we are in no way astronomically special. In terms of the physical laws that govern the motions of the objects in the universe, the Earth is but one planet, orbiting a small star in a medium-sized galaxy, likely one of trillions to do so. And while the question of whether humanity is alone in the cosmos is an intriguing one, there is no credible evidence to suggest that there is intelligent life elsewhere in the universe, even as the odds in our long history of recognizing that we are not unique would suggest otherwise. As the astronomer and author Carl Sagan has said, "We are but one small, pale, blue dot in the vastness of the universe," a truth which should more profoundly affect our decision-making as a species.
In western lands, beneath the sun, the flowers may rise in spring. The trees may bud, the waters run, the merry finches sing. Or there may be, 'tis cloudless night, and swaying branches bear the elven stars as jewels white amid their branching hair. Though here at journey's end I lie, in darkness buried deep, beyond all towers strong and high, beyond all mountains steep. Above all shadows rides the sun, and stars forever dwell. I will not say the day is done, nor bid the stars farewell. J.R.R. Tolkien.
So among all of this grand language and sweeping scope, what are we to make of it all? For me, the journey of the last 2.5 years still comes down to a single touchstone, that of the apprentice navigator with whom we sailed at the beginning of this series, that thing that he looked at, the night sky. Recently, I purchased my first, I guess I'd call it largest telescope. One of the perks of working at a college, being a college professor, is that the institution usually has a scope or two for you to use, and so for years I've sort of relied on that. But about 6 months ago, I realized that what I really wanted was to be able to use the telescope to look up whenever I wanted. And so it was that I bought a 6-inch Schmidt-Cassegrain reflector to view various objects in the night sky. Whenever the weather here in the south has cooperated, I've very much enjoyed observing the planets and various deep sky objects, much as William and Carolyn Herschel did some 230 years ago. However, to be honest with you, what has surprised me is how much time I just spend looking up at the sky without the scope. My favorite thing is to find an open location and set up at around sunset, and then settle in to watch the sky change color and hue, to observe that purple-pink glow above the eastern horizon not long after sunset, known as the Belt of Venus, and then to watch for the first stars to appear. You know, in the Abrahamic traditions of faith, it is watching for the day to begin, as it's said that the night belongs to the day that follows it, or, in the words of Genesis, it was night, and then it was day, the first day. As we pull up to the dock and throw our mooring lines over to whoever may catch them, this is what I want to ask you to do again. Take the time to go out at night and just look up. Look at the heavens. See the stars. Get away from the city lights and just observe. Observe the night sky. It's the same request I made some 30 months ago, but now I ask you to do it again with an appreciation of all of humanity's experience. Know that the sky that you look upon is more or less the same one that the Native American shaman and the Chinese scholars observed. What you're seeing is what Ptolemy saw and tried to explain. So too Regiomontanus and Copernicus. It's the same sky that Tycho Brahe saw when he looked up on his way to catch dinner in a pond and saw a new star and realized that everything had changed. Whether it was the ancient peoples at Stonehenge, Islamic hakim at mosques around the various caliphates that ranged from modern-day Pakistan to Spain, natural philosophers at the medieval universities, or post-Newtonian savants, philosophers, and eventually scientists. By looking up and observing, you join their long lineage. You become another astronomer who seeks to identify and understand the patterns of the heavens. It's a long and proud tradition, and we'd love to have you join us. I think for me, the most humbling realization is that as I watch that slow procession of stars from eastern horizon to western horizon, I'm joining both Halley and Eddington, two men whose fortunes were tied to a tiny island in the Atlantic, Prinkeep, in seeking to understand the cosmos in which we all have found ourselves in. Of course, the sky itself doesn't change because of all of that. It's the same sky. It's governed by the same laws of nature that were first described by Newton and then clarified and expanded upon by Einstein. And yet, nevertheless, as I observe it, I find that my appreciation for its beauty is enhanced and deepened by what I have learned. I hope that as you reach the end of this journey, that will be true for you also. While the history of this endeavor is a story of and for the ages, it loses something when we forget to tie it to the thing that inspired it, the nighttime sky.
The moment when, after many years of hard work and a long voyage, you stand in the center of your room, house, half-acre, square mile, island, country, knowing at last how you got there, and say, I own this. It's the same moment when the trees unloose their soft arms from around you. The birds take back their language. The cliffs fissure and collapse. The air moves back from you like a wave, and you can't breathe. No, they whisper, you own nothing. You were a visitor, time after time, climbing the hill, planting the flag, proclaiming. We never belonged to you. You never found us. It was always the other way round. Margaret Atwood.
So, where do we go from here? Well, for a time, we need to restock and resupply. I have a lot of reading and research to do for our next topic, and who doesn't like a little shore leave? However, I don't want to leave you waiting while I get enough knowledge under my belt to resume writing. Therefore, what I'd like to do is a short mini-series on some topics in the philosophy of science. Think of it as a bit of refitting of the ship before we set out again. Instead of replacing worn sails and rotted timbers, we'll take some time to look at the problem of induction and perhaps a few related issues. After that, we'll set out again on a new journey that's related to what we've just finished. If this series has been titled Finding Our Place, the next voyage will set sail under the title Finding Our Way. So as we wrap up, a few figures. It's been 114 episodes, about 85 hours of time. It's some 825,000 words to make this journey. That's a college course, minus the exams and homework, of course, worth of material. I've read more than 50 books, dozens of articles, countless websites, and drawn from many years of personal experience to present to you this long story. Over the time, I've gone through a lot of changes. I went on sabbatical. I got run over by a semi-truck. I developed and taught a class from the material of the podcast, and so much more. I'm sure the nearly 1,000 of you who regularly listen to the show have a similar diversity of experience. I wish I could sit down with each and all of you and lift a glass of celebration and hear what you have seen in our time together on this voyage. More than anything, I want to say thank you for coming along with me. It's been great knowing you're out there, and that when I release a new episode, you're willing to let me into your space in this strange and mysterious way that podcasts have. As I've said before, I'm honored and humbled that you make time in your lives for me. In a few closing notes, let me offer a few other thanks. My appreciation to all of my colleagues who have endured numerous questions, musings, and thoughts as I've tried to work through all of the material, especially Todd Timberlake at Berry College. Thanks also to the Blue Dot Sessions, whose compositions have provided the soundtrack for this entire series. To the folks at Libsyn who've hosted the show, thanks for doing what you do so well so that we podcasters don't have to worry about the technical details of getting a show out to our audience. Last, but certainly not least, I want to say thanks to my lovely wife, Kathy, who has been so generous of her time so that I can hole up here and write and record this show every single week. She puts up with the clutter of books, my disorganized and rambling mutterings about writer's block and not being sure how to tell the story and not being sure I'm doing a good enough job and being all insecure about it. The having to have a mini recording studio in the house and then having to tiptoe around when I'm bunkered down in it, and all of the other things that go on with just having to do a podcast. Very fortunate to have such loving support. And if you're the sort of person to offer up thanks for this podcast, be sure to give thanks for her too. I know that I do. Next time, we'll begin a discussion about just how much trust we can place in scientifically arrived at knowledge. Until then, full sails on your journey.
The sea was sapphire-colored, and the sky burned like a heated opal through the air. We hoisted sail. The wind was blowing fair for the blue lands that to the eastward lie. From the steep prow, I marked with quickening eye Zakynthos, every olive grove and creek, Ithaca's cliff, Lachion's snowy peak, and all the flower-strewn hills of Arcady. The flapping of the sail against the mast, the ripple of the water on the side, the ripple of girls' laughter at the stern, the only sounds when again the west to burn, and a red sun on the seas to ride, I stood upon the soil of Greece at last. Oscar Wilde.